So meanwhile, I have the pleasure of reuniting and with Carlos, Dr. Jimenez-Bescos, and strangely enough, me and Carlos met in a similar workshop, which I organized a few years ago, and we've stayed in touch through the last few years, which goes to show the power of such workshops. So Dr. Carlos, thank you very much, and I would like to hand over the floor to you to talk about design opportunities for the built environment post-COVID. Thank you, Carlos, and if you're able to switch on your camera as well.
Hi, thank you very much. Really thank you to the organizers and to Pretty, thank you so much. We met a few years ago, and like you said, we're still in touch. Perhaps something I forgot, the good relationships that you get from this kind of workshop as well is it lasts for years and quite a lot of collaborations happening. What I would like today to talk about is just a little story on data, on monitoring data for passive houses, and to see how we can actually apply it for the point of view of a new normal that we are coming into with after and during the COVID pandemic. So obviously we have changed the idea that we have about the indoor spaces that we have, about what is indoor air quality, indoor environmental quality. I think we have seen along the day a lot of different presentations talking about, for example, how people now want to be changing houses, or they want to be in better houses with, and certainly much better ventilation. I think that's one of the main points that has come out, is that we want to have better ventilation because we want to be in a healthy environment, and that will be for getting rid of pollutants, or avoiding COVID, or it's as well a question of thermal comfort. So nevertheless, we need to think about reducing energy and being thermically comfortable. So passive house is been around now for many years, and we really understand them very well in cold climate. But to be fair, it's expanding massively into hot climate. We've been doing quite a lot of research into more challenging opportunities, but it's spreading quite well. And basically, if we want to summarize very quickly what it will be, a passive house is basically a fabric first approach, where we work very well on the fabric of the building. We create a really good air tightness, so our infiltration losses are minimal, really small. But of course, because we tied up the house so much, you end up having to have a mechanical ventilation system. But I think the biggest problem that we have with passive house is the way that people understand how the building works. And that's why I commented on a couple of misconceptions always about passive house. One of them is that a mechanical ventilation system with heat recovery is going to be working the whole day. Well, that's not actually true, because obviously we want that mechanical ventilation system working through the winter, but in the summer you are basically opening your windows. So in reality, you need to, the user needs to learn that this is how the building is gonna be working. And of course, it comes out to the second point that I said there: windows need to be open, because of course, if you have a summertime with an increase on solar radiation and you keep your windows closed, unfortunately, what happens is that you are going to have overheating, because you are supposed to open those windows. So perhaps there is a bit of work to do in telling people how to use it, but there are many benefits. I just wanted to highlight what is a mechanical ventilation system with heat recovery, the way it works in a simple, compact system for a passive house. I'm talking about domestic, and the main thing is that you got a couple of filters. Okay, obviously the filters, the filter that is coming from the outside is actually a G7 filter that is a stop really small particles. The one that is filtering the inside is not as good, but of course it's not as expensive as well. So we are doing a little bit of work about, you know, what can we actually do with this filter and what is captured there. If we can use it for example, trying to analyze how is the air quality in the houses and actually from the outdoor as well. The other important thing is that many of the issues that we are seeing at the moment is that you cannot be recycling the air, because if, for example, there is any kind of contamination, you are just basically spreading it even further. And that was probably one of the surprises that we've been getting with COVID, is that, you know, you need to open windows, you need to have fresh air. So in any of these systems is fresh air all the time. There is no any kind of recirculation happening. The only thing is a non-physical transfer of the heat from the indoor to the outdoor, but there is no physical contact or contamination at all. So that's probably a good thing to have in terms of having a mechanical ventilation system. And just borrowing a quote from Peter Drucker, who was very much involved in management, but it really applied to us very much. It's basically, if you don't measure it, you cannot improve it. So we talk so many times about having good ventilation or having really good thermal comfort. Yeah, but if we don't measure it, there's not much we can do. I think I'm really impressed by the work that we've seen today on how much monitoring is actually happening and the scale of that monitoring as well. So I will tell you just a little story about two houses. So we got on the left-hand side, we got property A. On the right-hand side, we got a property B. I put them more or less to give you an idea of the scale, of course. Property B is very big. It's about roughly the size of 2 or 3 average UK houses. Both of them are placed in London, not far from King Cross station. And just to give you a little bit of background about the two properties, the property on the left, there is basically a more simple approach. So both of them are NR-fit Passivhaus. So basically they are retrofitted according to the Passivhaus standard. But on the left-hand side, on property A, it is a much more simple approach. So basically the fabric has been upgraded to Passivhaus level. The air tightness has been upgraded as well to that retrofit level that we need to achieve. But it's only using mechanical extraction. So it's not using a whole mechanical ventilation with heat recovery. It's only using mechanical extraction. And the expectation is that the users of the house are going to be opening windows and closing windows as they need and when they want to. On the other hand, the property B on the right-hand side is more of it's a much bigger property, but as well it has all the technology almost that you can be thinking of. So this property has, because of the size, needed to have 2 mechanical ventilation systems with heat recovery. It has a solar thermal. It has a couple of heat pumps for heating and hot water. It has a lighting system. It has anything that you can think of in terms of technology.
Sorry, this is a 2-minute warning for you, Carlos. Thank you.
I'm sorry. So the reason is to really go and look at, I have just a very simple system to measure temperature and humidity. We are measuring in about every 60 minutes, but we are more interested as well on the CO2 concentration that we are having every 15 minutes. So if I compare the graphs, the property A, what is the most simple approach, we are looking into the temperature being in the range that we are expecting. We designed for 20 to 21 degrees. That's where it's staying. And on the other hand, the property B that has all this technology installed, we have a lot of overheating. We look at this, and this actually is winter. Many of the times that we are at 24 or 25 degrees, it's actually overheating massively. In terms of humidity, both of them behave very similar, away from really what is a problem of 70% or higher, where we have a quite healthy level in property A. And property B, again, very similar, maybe a little bit more dry because, like I said, we have a couple of ventilation systems that are basically over drying the air, so that the humidity get much lower, but well away from any trouble. And quite interesting is what we're looking at is less than 1,000 CO2 concentration. Obviously, now with COVID, we are using it as well as a measure of to know when we may have some problems. So it's quite nice to see how we are very much away from these troubles in the smaller property in a more simple approach, and it's pretty similar to what we have with a house where we put all the technology to really work. So for me, the conclusion and what you can see from looking at different approaches is that technology by itself may not be the answer. That something is going to be successful. We need to achieve flexibility. We need to give the users the option to be able to interact with the system, to be able to work with the system. The main reason for me is because obviously we have a kind of two different routes. One where they want technology to drive everything and to take the people away. And on the other hand, there are people like myself that think about that much better to actually work with the users, help them to really understand the building and help them to make it comfortable for themselves. And I think the data is clearly showing that CO2 concentration are very well under control, no different between one property or another. And in thermal comfort, it actually seems to be much easier to achieve in a simple approach where people can actually work with the way that they feel about the thermal comfort and the state of the house. And I think that's probably give the opportunities for more retrofitting in this approach.
Thank you very much, Carlos. Thank you for a very interesting presentation. I've posted a question in the chat box.